We're going to look at making a reduced order model, commonly referred to as just ROM. This is our simple geometry, which consists of two inlets and one outlet in a partitioned room. We're going to vary the inlet velocity of these inlets and visualize the results of the velocity magnitude with our ROM. The first thing that we'll need to do is create a simplified mesh. So I'm going to use Fluent with Fluent Meshing. I can just drag and drop that geometry into my mesh and double click to launch the Fluent Mesher. I'm going to use 4 processes to make the mesh and the simulation run quickly, but I'm not going to check double precision. That's just so I can get results quickly. A lot of what I do in this tutorial will be reducing the accuracy of the solver but increasing the speed purely so we can get our results as quick as possible. We're going to go through our workflow, and the first thing we'll do is import our geometry. I will keep pausing the video as this loads such that there's no unnecessary extension of the video length. Now the model is imported, we've got a green tick next to geometry. We don't want to add any local sizing, so we'll just press update. We're fine with the default surface mesh settings, so we'll press create the surface mesh. We have to describe the geometry. Well, this geometry only consists of fluid regions with no voids. That's the option we'll select. Our boundaries are assigned correctly automatically based off their name, so we'll update. Our region name solid, well, although it says solid, this is actually fluid, so it's assigned that correctly. That's fine, we can update. Do we want to add inflation layers? Yes, we do. We'll keep that as 3 by default. Finally, we can select generate the volume mesh, and instead of polyhedra we'll use poly-hexcore mesh, and we'll generate that mesh. Once the mesh is generated, you get a preview of how it looks. It's doing a clip plane automatically, and you can see we've got a nice mesh. It's fairly coarse, but for the purposes of demonstration it will be more than suitable. At the top left we can switch to solution view, and that will take us to Fluent, where we can assign our boundary condition and our model settings. So we'll click switch to solution and press yes. Now we're in our workbench environment. The first thing I'm going to do is go to the console and type in define models add-on module 11. That will bring the ROM builder into the Fluent workspace. Now that's done, if we click the tick on the models, we'll see this reduced order model here. We'll come back to that after we've set up everything else in the Fluent workspace. We're going to go to our boundary conditions, and we're going to edit inlet 1 and inlet 2 such that these become parameters. So instead of a velocity magnitude, we'll select new input parameter, parameter 1, and that's fine. Apply and close. We'll do the same thing for inlet 2. Instead of a velocity magnitude, we're going to do a new input parameter. Let's give it the name parameter 2. Obviously you can change this if you want. For now it's fine. So OK, apply and close. Let's go to our methods. We're going to choose some schemes which will make the simulation faster but possibly not as accurate. So I'm going to go to the simple pressure velocity scheme and change all of these to first order. In my run calculation options, I'm just going to select a very low number of iterations purely for the purposes of demonstration of 35. you would want to do more and check that each of your results do converge, but for the sake of speed we'll leave that as 35. Next we're going to go and actually initialize this simulation. I do that so I can set up an output parameter. We need both input and output parameters to make our ROM. I'm going to go to results, surface integrals. I'm going to select an area weighted average of inlet 1 and inlet 2. There may be something more useful that you want an output parameter of. I'm not really bothered about it for this demonstration, I just need an output parameter. So I'll create a new output parameter, parameter 3, and that's done. Now if I look at my workbench, I've got my parameter set here, where I can enter values and run a parameter set, but we're actually going to use a design of experiments to generate all those parameters for us. We could create some contours now which would be automatically imported into our ROM when we view them. So if we make a new surface, we can make a new plane through the middle. There wouldn't be much interesting to see on that now, as we've only just initialized the simulation and not run anything. But we've set up everything we need to do. We've got our input and our output parameters. Our fluid was air by default. We just need to make sure we enable our reduced order model. So we'll double click, we'll press enable reduced order model. Now we select what we want to make a reduced order model of. We'll select the velocity, we'll select everything in terms of our zones, and we'll add these to our ROM. Obviously the more parameters that you have, and the more places you have them, the longer it's going to take to build your ROM. So we'll press OK, that's all set up, so we can go ahead and close our Fluent window. So we're going to go down, and if it's not already expanded, you'll need to expand your design exploration. We're going to select 3D ROM. We can just simply drag and drop that into our workspace. First right click design of experiments and press edit. Here we can select our upper and lower bounds for our parameter study. So for parameter 1, our lower bound is 0 and our upper bound is 5. And we want the same for parameter 2. That simply means our velocity range is going to be between 0 and 5 meters a second. We can press update to view what these parameters now look like. It's going to investigate all these different parameters and generate an output for that. So everything looks fine there. We can close this. If we look at our ROM builder, we can keep everything as default here. Our number of modes defines the accuracy of our ROM builder. But everything looks good to go, so we can close this. We can go to our workbench and we can press update project. This will start running through all the simulations and all the design points, after which we should have a green tick next to each component of our investigation. This may take some time. Obviously the more iterations you're doing and the more parameters that you're investigating, the longer this will take. I'll pause this video now and I'll resume the video once the ROM has been created, or once the simulations have been completed. Right, so I've just unpaused the video now, and the simulations have taken about 14 minutes to complete, which isn't too bad considering we made a lot of the models run as quick as we could with our solver settings. So now you can see we've got a green tick next to everything. All we need to do is export our ROM such that we can view it later on in Fluent or in the dedicated ROM builder. Export the ROM, and I'm going to do this to my downloads. I'll just call it temp ROM. Now that's done, we can make a new Fluent workflow, and we can right click, and you see halfway down the list we've got the option to import ROM. So we'll do that. We'll go and find the ROM we've just saved, which is this .romz file. We can open that, and you can do this in a separate workbench if you wanted, but we can start the setup. We can select the number of processes, but as we're not actually running the simulation, it doesn't really matter how many processes we assign. So 1 would be fine. Right, that's the model loaded. You can see we've got 2 inlets and 1 outlet. We've not finished loading just yet. Here we go. So we can expand our models tab, and we can see that we do have our reduced order model option on here. But first, what I'm going to do is I'm just going to quickly initialize this simulation just so we can visualize the results. So I'll just click hybrid initialization. As you can see, that was done very quick. If we go into contours, I'll deselect everything, and I'll just select plane 4 and velocity, save and display. As you'd expect, that's 0. If we go into our reduced order model, we can go across to the evaluate tab, and here we can see our different inlet velocities, which we investigated between 0 and 5 meters a second. So if I put some values which are between 0 and 5 and press evaluate, that's actually just done. We just need to go and view those results now. So if we go to contours and we edit this contour, what we want to do, instead of selecting velocity, we want to go to ROM cell functions, and we want the velocity magnitude but of the ROM. We can save and display, and then we can see the corresponding velocity for that, for those 2 inlet conditions. If we wanted to see another set of results, we could change our inlet parameters. So let's do 3.5 and 3.5 as well. We can press evaluate, and our view has actually updated in our contour plot straight away. We could go to 5 meters a second for parameter 2 and evaluate. That's updated again, and if we go to our maximum, that's updated one last time again. We're not just limited to this view. We could make plots as well. We could make an XY plot. So I'll probably have to make a new line for this. So I'm going to display my mesh first before I make a line. Let's display this and increase the transparency. Perfect. Now I'm going to go back to my XY plot. I'm going to make a new line, and that line, if we find our coordinate system, is going to go from z is equal to 0 to 8, and we'll put that at a y height of about 2 meters. So if we go back and view that line and see how it looks, we've got it at the right height, but we probably need to move it into the middle of the geometry. To do that, I'm going to right click and edit the line and give it an X component of about 4 meters. If I save that, update my view, there we go. It's not perfect, but it's about in the middle of the flow domain, which is what I want. So then I can go to my XY plot, new. What do I want to view? I want to view my ROM cell functions. I can choose my component of velocity, maybe the y component. I want it on the line I've just created, but my line direction isn't along the x, it's along the z, so I can update that and press save plot. We've got our velocity here, but our x-axis, our x function axis doesn't seem to be ordered correctly. So if we tick this option in the box here and press save plot, there we go. Our results are nice and ordered now. Again, we could go back to our reduced order model and we could select some other inlet velocities to investigate. So 2 and 1.4 evaluate. Okay, and then if we view our plot, we'll have to update the order of our results again. So we'll just save plot, there we go. And we can see our updated velocity plot for those new inlet velocities.